Yeah, again, I'm just to all of you this session number 7, A2, ATAL FDP IISGT 21. Vasika has already joined us, Mr. Rajkumar from AI Solution Engineer. I just request my colleague Chandrika to introduce the speaker and with this we can start the session. Chandrika, madam.
Thank you, madam. Good morning, everyone. Good morning, sir. A warm welcome to you to the session, sir. Myself, Chandrika Wadrevu, Department of IIIE Gayatri Vidya Parishad, College of Engineering. I take this opportunity to introduce our guest, today's chief guest, Rajkumar, sir. Rajkumar sir has graduated as Electrical and Electronics Engineering from Anna University, Chennai. Currently, he is designated as Senior Application Engineer in VI Solutions, Bangalore, and handling the major responsibility of supporting various industries in implementing several turnkey systems and system integration projects using NI products. He is also handling the major responsibility of improving the quality of engineering and science education and eradicating the improvised methods of education and inculcating the interest of LabVIEW. Rajkumar sir, as a CLD certified, has traveled far and wide throughout India and has delivered thought-provoking lectures which inspire the students and kindle their interest towards LabVIEW, and also visited 75 plus engineering institutions. He has conducted more number of hands-on training to engineering students of various branches on LabVIEW basics and data acquisition. He also had conducted many faculty development workshops on various trending technologies including embedded and control design, image processing, etc. He has delivered 100 plus lectures on experimental engineering education on varied technology topics. His key interests of areas are measurement and automation, sensors, data acquisition, and signal conditioning. A warm welcome you, sir, to this session. I request you to continue this session and address the gathering, sir. Thank you, sir.
Thank you very much, ma'am, for the warm welcome. I'm really honored to be here as a part of this ATAL FDP at our premier institution. With that being said, it was really a good, introduction about me, and I felt really honored among the attendees as well as the panelists to be a part of this session on implementing industrial Internet of Things using one of the tools which is commonly used in measurement, monitoring, and control. So with that being said, let's just jump immediately into our session for the day. And once again, thank you every one of you to have me here as a part of this session. So I'll just share my screen. And I hope my screen is visible. So, is visible, then?
Yes, clearly visible, sir.
Yeah, thank you for the confirmation. In that case, I would like to continue the session. So today we are going to see about the IIoT architecture implementation using NI-Lab. And like introduction was for me was already done. Let me just introduce my company as well. My name is Rajkumar. I work as a senior applications engineer at VI Solutions, Bangalore. So VI Solutions is a company which is specialized in test, automation, and control system implementation using several hardware and software products. And we are partners of technical partners of a company called as National Instruments. I'm sure everyone would have heard of National Instruments. National Instruments again is a company, okay, which specializes in test, automation, and control using both hardware and software products. Okay, the famous software product is called as LabVIEW. LabVIEW is a software which is used in implementation of programs which is graphical in nature, and not only is it graphical, it's also capable of interacting with several industry variation hardwares and embedded systems with minimal coding, as well as programming nature also is very easy compared to other text-based programming. And NI also provides several hardwares which are meant for condition monitoring, remote monitoring, testing of electronic products, etc. etc. So we are going to see how we can implement IIoT architecture using LabVIEW. Okay, to be honest, IIoT architecture is very large. It's not only specific to NI technology or LabVIEW. Okay, it can be implemented with various toolkits. Various companies have come up with their own solutions, but we are going to see how LabVIEW can fully implement from scratch, from start, okay, the IIoT stack. But before that, let us try to understand what exactly IIoT is. Okay, I'm sure everyone knows about what IIoT is. Okay, because the only thing is to increase, extra air is to one more eye. Okay, but I'm sure everyone knows about that as well, right? So IoT is used in industry. Okay, for industrial applications, is called as IIoT. Okay, industrial Internet of Things. We also have the other subset of IoT called as CIoT or normal IoT. Okay, which is used for commercial purpose, or also called as commercial Internet of Things. Okay, which is used for commercial, residential, or normal purposes. Okay, which does not involve traditional industries. But nowadays, industry is a very broad term. Okay, it's not like only industries in machine, in manufacturing, or only in in offices do we implement industries. Okay, so even your home can also be an industry. Okay, as in residential industry is one type of industry where it is concerned with home automation and stuff. So that also is in the industry actually. Okay, but here we talk about specifically industries, means we talk about a traditional industry. Okay, that could be a city, or that could be a manufacturing plant, office settings, etc. etc. Right. So today's agenda is going to be, we are going to see what exactly is IIoT is, and what is the architecture behind it, what are the components of that architecture. And not to implement this architecture, okay, we are requiring some tool. So each and every aspect of the architecture needs to be implemented by some other programming language or other. Okay, so although any programming language can be used, our objective is to make it simple for a very specific user. Okay, now IoT is a specific branch which has specific set of people dedicated to program an IoT system. Okay, they are very specifically required to know embedded system, okay, to create things, and they'll be knowing about technology stacks like full stack programming, like web page design, okay, and cloud maintenance, etc. etc. So there is a specific branch which deals with that. Okay, but we are a branch of engineers and scientists, where we are required to create our own application with minimal programming knowledge. Okay, because we already have our own set of problems, like we need to be focused on monitoring grid. Okay, in grid we'll be monitoring voltage, current, frequency, and apart from that we have several other parameters to worry about. And programming language should not come as a problem to us, right? So we should not be focused on how to create a programming methodology, okay, to create, to make use of our applications. Our focus area should be about our domain knowledge. And in order to implement that, we need to have tools which is easy to be used by engineers and scientists and make use of it. right? So how do we solve that? Okay, so we make use of LabVIEW for it. Why, how LabVIEW, and when to use LabVIEW, we will be seeing about. Okay, but let's just understand about what exactly the IIoT is. And of course, everyone knows about what IoT is. Okay, IoT is a framework or a methodology where a thing, okay, or any aspect of the component can be connected to internet. Okay, instead of having several layers to be connecting when data to be reaching the servers. Okay, the thing or any device can directly, it should be having intelligence. Okay, it should be having ability to think, it should be having ability to process, and it should be having ability to communicate. Right, so a thing to be directly connecting to internet is going to be called as Internet of Things. Right, so it could be a person also, okay, a person with intelligent electronics. It could be a business, okay, it could be industry, it could be anywhere, okay, it could be moving or it could be stationary, it could be in remote locations. Okay, but this thing is going to be connected to internet, and at any amount of time, at any instant of time, okay, it's going to be connected to internet. Okay, there are differences between IoT and IIoT, of course. Okay, we have industrial Internet of Things, where we'll be monitoring, monitoring and controlling status with respect to transportation. It could be transportation industry, power industry, factories. Okay, grid. I mean, of course, we have separate session to implement monitoring system using the IoT formula. Okay, when the time arises, we'll do that, of course. Okay, I will be monitoring smart machines. Okay, in from a remote location. So what is to be used? Those things we already see. Okay, or it could be a automated vehicle. Okay, so it could be autonomous vehicle, or it could be industry manufacturing plant. Okay, which is going to be monitored. So these are very specific to one domain. So that's going to be industrial Internet of Things. Okay, we also have another subset called consumer Internet of Things, which is used by normal people in a normal setting, residential settings, or for personal use. Okay, it could be a smartwatch, smartphone. Okay, phone we didn't consider phone as a thing. Okay, but phone can also be remotely monitored, and it can be applied for analytics, etc. And wearable technology, smart TV, smart appliances, those things are also a separate set of applications which can be connected to internet, monitored and controlled. And both of these industries can generate a lot of data which can be subjected to analytics, okay, and derive some insights out of it. So ultimately, observing is not going to be called as Internet of Things. Okay, so that's going to be just called as a remote monitoring system. What makes it Internet of Things is it should have an ability to acquire data remotely and also be able to derive insights out of it. Okay, so that is application of data analytics. So if your cloud, okay, is going to have some way to implement data analytics, then that is going to form a way to implement this Internet of Things. So where do we use this IIoT? You might ask. Okay, so it's going to be used in several ways, but for our applications. Okay, so it's going to be used in control systems where time is very sensitive. We have something called time sensitive networking, where it should not have any delay when transportation latency, as we call it. Okay, so in manufacturing plants, we should not be having any delay. Microsecond delay or nanosecond delay only can be applicable. So this should be in a place where you require IoT. Okay, where we require IoT is in time sensitive networking. Or let's say you want to monitor something remotely, not only to monitor. Okay, we should be able to do predictive maintenance. Okay, so let's say you have like some grid or some machinery to be monitored. Okay, so that condition could be monitored, okay, remotely. Not only will we be able to monitor remotely, we should be able to derive insights of its maintenance tasks. Okay, so let's say you have a manufacturing plant and you have like motors running 24/7, and you collect data with respect to that condition monitoring. Okay, with that data, you should not just be logging the data for the sake of logging. Okay, you should be able to derive some insights of when that motor is going to fail. So by applying some machine learning, you will be able to derive an insight, okay, called as predictive maintenance, where you can see the continuous degradation of that machine, okay, by collecting parameters like voltage, vibration levels, and several other parameters. Okay, you can say, okay, this is degrading over a period of time, okay, very long period of time. You could observe the changes in its pattern, changes in its behavior, and once the behavior has gone too far, okay, the change is too much, okay, you can apply some predictive maintenance and you can say, okay, this is going to fail. So this level of flexibility can be employed, okay, by using IIoT, because IIoT, in the sense, these machines will have smart sensors connected to internet. It will collect data and will be putting it in a remote server, and that remote server will have services with respect to machine learning. It will process the data and will derive insights like when it's going to fail or something. Okay, not only will be able to monitor the machines, okay, like generators or motors, we'll also be able to synchronize your grids as well. Okay, microgrid communication. Okay, so when you have a grid, okay, so which is from a renewable energy, so each and every renewable energy is going to generate its own frequency or own level of voltage. So basically this will have a inverter which is connected to grid, okay, and this needs to be synchronized. So some sort of synchronization signal must be sent, and this must be sent for every every of these components at the same time, okay, and controlled. So IIoT can be used to get this grid waveform data, and based on this grid waveform data, it will be able to synchronize it, right? So these are the applications of IIoT commonly used. Okay, but why do we need to use the IIoT? Why do we not use a specific processing plant, okay, very commonly used for that location alone? Okay, why do we need to have a distributed system? So there are advantages, of course. Okay, there's going to be, every time there's going to be an advantage. Okay, so ultimately you need to have a system which is going to be scalable. Okay, so when you have a mission, when you have a industry, okay, it's not going to be unique to only one place. There is a chance that you are going to have a copy of the same industry somewhere else, right? So in order to monitor only one system, okay, you could possibly have a scalable system where the same set of parameters will be monitored over the world, okay, by using some trustworthy systems. Okay, so basically companies have, whoever uses IoT systems, okay, they have said that by making it scalable, okay, they were able to acquire the data remote manner, okay, and they were also able to process it in a remote location and able to control it from a central location. Okay, by doing, they said that they were able to reduce the losses, and they were able to reduce the downtime, okay, by 80%. Okay, so how is it possible? In a sense, instead of setting up a monitoring station everywhere, okay, they were able to monitor it from a central location, okay, and they were able to monitor each and every plant, okay, from a remote location. And by doing this, since data was available in a central location, they could make use of a team to derive some insights and apply some sort of fix for any problems that might be fixed, right? So by employing IIoT, they were able to set up scalability. And since IIoT systems have, you know, increased in abundance, okay, many devices like many devices were required to be connected to internet in order to facilitate remote monitoring and remote control. Okay, so IIoT was implemented, and due to the implementation of IIoT, several insights were derived. Like by 2020, okay, now 2021, okay, they said that 50 billion devices will be connected to internet. Okay, so that was the estimate, but I believe it is more than that. 75 to 100 billion devices are now connected to internet, right? And out of that 50 percentage, okay, of them was deployed for industrial purposes, right? So 50 percentage was estimate, of course. Then like 60 percentage was required for industrial purpose. Okay, remaining 40 percentage was employed for residential purpose. Right. So what do we really require? Okay, to employ this. So there will be something which is going to help us implement this, right? Of course, there is the architecture, okay, proven architecture, which is to be employed for the sake of implementing our IoT architecture. Okay, there are three things which is required. Number first one is think of IoT. Okay, so when I say think for commercial of things, that will be like a sensor which is going to monitor, like, let's say, temperature. Okay, let's say smart thermostat which can be controlled from anywhere over the world. Okay, or smart microwave oven. Okay, which can pull out the recipe and say this much amount of heat must be applied for this much number of time. Or you can say smart fridge which can continuously analyze if something is some item is going to be reduced or going to be finished within within the given amount of time, or maybe the milk is going to get spoiled. Some sort of sensing device could be employed. Okay, so sense, process, and make decisions. Okay, so that will make sense for commercial internet of things because these are commercially used at home for specific purposes. And these devices are required to be connected to internet and make decisions. Okay, similarly, in industry also, there will be several items which need to be monitored. Okay, so these things could be operational assets like motors, air conditioning units, or it could be production equipment like conveyor belts, or pick and place robots, anything. Or it could be to transport an equipment from one place to another, or that transportation device. Okay, that is also considered as IIoT. Okay, in fact, you can control this device from remote place and also help them make decisions or get some diagnostic information about that machine, whether that machine is going to fail or whether that machine is going to be, whether the system requires some maintenance, okay, scheduled maintenance, when it should be scheduled. Those type of insights can be derived. Okay, and since LabVIEW is used in test and measurement industries, sometimes we might be doing tests from remote locations. Okay, so not every time should we have a person monitor this test. So in order to automate this testing things, okay, we need to do it from remote place. Okay, we could implement IIoT for that as well. So these are basically going to be the source of data for your IIoT. So once that is done, we require some operational technology. Okay, so these are the things of IIoT. Okay, so if you see tests, okay, so there's something like ATE. Okay, ATE stands for automated test equipment. Okay, test cells, chambers, basically used for testing purposes. Okay, and production equipment, okay, like packaging machines, CNC machines, okay, those things, if you want it to be, globally monitored and globally controlled. Okay, so you require some IoT systems and operational assets. like turbines. Okay, in case of power equipment, okay, power generation equipment. So that is going to be running 24/7. Okay, you need to monitor its asset. It's an asset to be monitored, and if some problem occurs, okay, we need to employ some systems in place to prevent the downtime. Okay, so downtime not only applies to turbines, even grid will have problems, okay, of downtime. Okay, we need to know when exactly the grid will go down, and we should be able to, at least, if we will not be knowing exactly, okay, we should have at least an insight of when it might go wrong. So when we know the exact date, okay, we'll be able to make some prior arrangements to prevent downtime issues. Okay. So by employing this in these domains, okay, you can see that when we employ IIoT, okay, so since it can not only acquire data with respect to that machinery, okay, they were able to make this for several purposes, okay, like predictive maintenance and etc. Okay, by doing so, they were able to increase the uptime. Okay, so when they know when the predictive maintenance is going to be done, right? So they were able to prevent the downtimes. Okay, before the actual failure, they were able to do some maintenance, and they were able to prevent that actual fault from occurring. So the thing what will happen is, if we know when exactly the problem is going to occur and when we fix it beforehand, okay, that the maintenance part, okay, is not going to take that much time. But if we have a unscheduled main breakdown, okay, in that case, we won't know whether the person who is supposed to fix it will be available at that time. If he is available, yes, okay, fine, okay, then we can proceed for fixing. Okay, but most of the times we will not be having the person readily available. So the solution is, we have to wait for him, then we have to apply solutions for it. Okay, and waiting period might be from few days to few weeks, and that is going to add more overhead. Okay, and when we can do this remote monitoring, okay, the performance also is increased, because we'll be able to do it from a centralized location for same copy of objects from several places. Okay, so that is there. Okay, so once we get the data from these things of IIoT, okay, next is going to be an operational technology. So operational technology is opposite to information technology. Information technology is software based. Okay, so where it's going to just acquire data and process it in real time. Okay, but operational technology in the sense, okay, the hardware part. Okay, the hardware and firmware part of your thing, which is to be monitored. So in this case, if you see, we have something like sensors and actuators, and this sensors and actuators will connect to your computer. Okay, not direct computer. Okay, we'll have some embedded system. This is to be connected to internet. Okay, and this embedded system should be capable of measuring voltage, current, digital input and output, and several other custom protocols. Okay, this is happening because sensors and now people might ask, why can't we directly connect this operational asset directly to this machine? So mostly your operational assets will produce phenomena. Okay, either it might produce phenomenon of, let's say, vibration. Okay, so vibration data cannot be rarely read. Okay, we need to know, we need to have a separate system which will help you do that. So yeah. So once that is done, in order to monitor this data, okay, from the operational assets will, let's say, it will produce voltage or current. Okay, you need to have an intermediate device, okay, which is capable of monitoring this data. Okay, and there is nothing but your sensors and actuators. Okay, you may have temperature sensor, you may have pressure sensor, you may have vibration sensors, force nerves, anything, right? So which needs to be monitored of these parameters. So we can directly connect it. So we need to have an appropriate sensor to convert this data from your operational aspect to something which can be understood by your computer. So that's why we'll have sensors and actuators. This sensors and actuators job is basically to convert the parameters from your machine, okay, to let's say voltage. Okay, so basically your machinery can read voltage or current or frequency. And in order to read this, you need to have sensor to convert this physical phenomenon into voltage or current or frequency. And once that is done, you will have other set of hardware which will convert this to these parameters to voltage. Okay, and this voltage can be read by an intermediate computer called an edge node. Okay, the edge node's application is to connect, to acquire this data. Okay, not only is it to acquire this data, this edge node is typically an embedded system with internet connection. Okay, so it will be able to send this data to a company. Okay, which is required to do insights. Right? So this embedded system will be capable of acquiring the data and will be able to transfer the data to your cloud, or it could be to a computer, okay, through a common infrastructure of data transfer. Okay, this infrastructure could be commonly accepted protocols, electronic protocols to make connection to. And once you get the data to cloud, okay, through some common interface, okay, so you could basically make it do anything. So basically, you might need to process data on the premise itself. So you'll be having a computer, okay, which is able to process the data, or you might have information technology based information on computer, okay, cloud based computer. So which is going to have much more processing capabilities. Okay, so this is what is going to be the edge. The edge is not only going to, it's not going to be a full component. Okay, edge is basically the IoT plus operational technology. So only when you combine both of them together, will be able to develop it. Okay. So you might ask, what are things which are required, which have to be done by LabVIEW here? Okay. So like, if you see, we have data acquisition to be done. Okay, we need data processing and control simulation, communication, security, data management, machine learning, visualization. So these are some of the things which can be done by your data acquisition hardware, right? So what is next then? So once you got the data by using the window, you will have you'll have hardware, okay, which will be able to connect to computers, okay, and it will be able to connect to internet, it will be able to process data, and will be able to display them in a format which you would like to do. Okay, then you'll have something like let's see what is there for you. Okay, so here they are saying that there's a commodity edge with respect to NI. Okay, which when followed, everyone can get perfect. Okay, in order to implement IoT systems, we might have different hardware used for different purposes. Okay, and depending on its use, so you'll have typical type of application to develop. Right? So superior control. Okay, this is open connected software. Okay, then superior control. Then you need rugged, synchronous hardware, accurate, reliable measurements. Okay, these are some of the things which needs to be done by your hardware. Okay, and software. But here you need to be very specific on what are not going to be things. Okay, because most of the people will say, okay, my computer and laptop is capable of doing all these things. Right? So things cannot be desktop, laptop, tablets. These are devices used for day-to-day purpose. Okay, partly for industry Internet of Things, these cannot be used as things in order to gather data and visualize. Okay, of course, for monitoring the status of visualization, we can use this, but directly for the production, okay, you cannot use this. Right? Then what can you use? Okay, so this hardware should be capable of being programmed. Okay, so IOs should be potentially be acquired data, which is acquired data from IOs. Okay, and it should have reliability, and not only should it be reliable. Okay, the programming language should also be easy to be done, and it should be able to acquire data from sensors. Okay, minimal programming requirements. Okay, and it should also be able to control something. Okay, in real world, and process the data, derive insights. Those things should be done. Right? So, like we said, there are plenty of hardware which are capable of doing this. Okay, but in NI terminology, NI technology, okay, there is a better way of doing it. Okay, so we have a hardware called as LabVIEW. Okay, which has all these combined, capabilities. Okay, so for connecting to the internet and doing some basic algorithms to complex algorithms, we have a processor. And when you want reliability, when you want some high-speed control, nanosecond-based control, okay, so you have FPGA there. Okay, and FPGA will be directly connected to sensors, actuators, and other type of things. So that capability is also there. And not to program this like normal IoT stack, people for different purposes they'll go for different programming tools. Okay, but since we are engineers and scientists, where we don't have time to learn a specific programming stack. Okay, so NI has made an effort to make the job simpler for engineer and scientist. So all these things can be programmed by only using LabVIEW. Right? So only LabVIEW is going to be used in this methodology. Okay, so using LabVIEW, we'll be programming the processor, FPGA, okay, for basically for this thing implementation. Okay, every stack will be done only by Lab. Why do we go for LabVIEW and this hardware? Okay, basically we have a set of hardware which is capable of be acting like a embedded system, and this embedded system is going to be like edge. Okay, edge is basically connectable to internet and also to sensors. Okay, and data acquisition and those things will be done by this edge device. Okay, and this control system implementation is also very easy. Okay, inside it, so on and so forth. Okay, so when we talk about IoT, we told that it should be able to now acquire data. So we have this IOs available, and for processing, okay, we should be able to think. Okay, thinking basically is going to be processing some algorithms. And if you see this processor in this hardware is capable of doing some analytics, real-time analytics, meaning as soon as it gets the data, it will be able to do analytics and present the data. Okay, decision making also we can do. Okay, if we program it, hardware program it. And for computation, also we can use this FPGA. Okay, where we need high speed, computation. Okay, so we have several types of hardware under the NI itself. Okay, but what we are going to use? Okay, we are going to use a very specific tool. Okay, this hardware is called as CRIO. Okay, if you see there is a this is going to act like a computer. Okay, and for IOs, since different IoT applications will have different types of IOs in it. Okay, so this is going to have a modular instrument in place. So if you want to replace the IOs depending on your usage, okay, you can remove these nodes and you can attach what is exactly needed for application. And if you see there is the Ethernet cable available here, okay, meaning this could be connected to internet. And this hardware will have an operating system. Okay, it could be Windows or it could be Linux. Okay, it could be real-time Linux. Okay, depending on your usage, it will have an operating system. And if you see there are USB cable. Okay, meaning you could basically attach it to a camera or attach it to a USB to accommodate more power. Okay, like more storage to be done. Right, but right now, let's say we don't have access to this hardware. Okay, this particular hardware, but we need to know how we can make connection to this hardware. What are things which we need to program this if we didn't know? Okay, so right now with me, I have a miniature version of this hardware connected called as NI-MIDU. Okay, so this is a miniature version with same capabilities as what we saw before. Okay, it is all the capabilities. Okay, only thing is instead of this modular IOs where I can, if I want more digital input output, I can remove other cards. I can have only DIOs. But let's say if I don't want to have one DIOs, I want only analog inputs. I can remove each and everything and only attach analog inputs. So customization is possible by using this device. Okay, but if I use this device, okay, this is basically to learn how to use embedded system using LabVIEW. Okay, this hardware is created for that. This is going to have 6 IOs. Okay, this is also going to have FPGA and ARM processor in it. And apart from that, it's going to have several other IOs. And moreover, this has a Wi-Fi, which means it can easily connect to internet. Okay, so using the IOs, you can collect data or you can control something. And that data will go to the processor, which can process it. Okay, and after processing it, you need to be able to communicate to the external world. So for that also, we need to use some sort of tools. Okay, so that connectivity is going to be by some computer. Okay, you can connect it to Wi-Fi, and this is going to be assigned some IP address through which we can communicate. Okay, there are many IOs available. Okay, here you can see about that. Right. So yeah, let me just immediately see how we can configure this hardware. Okay, before we start programming it. So right now with me, I have this hardware available. So you see, I will close this. So if you see, I can make the connection of this hardware. Okay, basically this hardware is USB connectable. Okay, USB connectable. Okay, at least for programming methodology. So once I connect it, you can see that once I make the connection, you can see it is assigned an IP address through which we can connect it to the systems. Okay, and there are many options as to how whether I can start programming it right away, or whether I can check what are the devices available on top of it. Those type of things I can do. And now what I'm going to do is I'm just going to go for getting started wizard. So once I get this getting started wizard, okay, it's going to say, okay, something is found. Okay, the Rio hardware is found, connected. Okay, it's going to check the software installed. Okay, if you want to change, you can change the name. And more importantly, this device already has some IOs inside the board itself. Okay, like for example, I have an accelerometer for which I can just change the orientation and I can monitor it. Right now it's connected via USB. Okay, but you can in future you can modify it in such a way that it's going to be able to connect to something else as well. Okay, maybe you can connect it via Wi-Fi and monitor it, or you can basically make it monitor via something else as well. Okay, you can connect it to a cloud and make it monitor. Okay, so I can also configure the hardware. Okay, so right now I'll just close this. Okay, for configuration, I have to open something called maps. Okay, basically this hardware does not have any display in it, so which means headlessly you should be able to change the settings with respect to that. Okay, and do that once you connect your computer to hardware, you can configure its methodologies. So I have this another software called as NMaps, with which I can monitor its status of that hardware. So let it open. So if I change the orientation, you can see that I'm able to see changes here. Okay, the accelerometer changes. Apart from that, I can control there is a LED available on board LED, on board my hardware. I can switch on or switch off. And there is a button here on board the Rio hardware. If I click on it, you can see that this LED is going to switch on stuff. So this is for testing whether the hardware is working fine. Okay, so you can make use of this hardware to create your edge device. You can make it use of the edge device because it has all the requirements of edge device. Okay, so like we said, your edge device should be intelligent. Okay, it should be able to deploy algorithms inside it. Okay, so if you see, I have this edge device connected, okay, to my system, and inside this edge device, you can find some information like what type of operating system. Basically, this is a computer, separate computer. Okay, and your devices, okay, your IoT thing should be, it should have its own thinking capability. So when the thinking capability comes, if you have an operating system, okay, which enables you to connect to internet, okay, and you can also deploy some applications inside it. Okay, so when you have an operating system, so if you see this has a NI real-time Linux inside it, and also it has the IP address assigned to it, meaning it can be connected to internet again. And more importantly, you can see that it has an inbuilt storage, okay, available inside it, right? And also you can configure network settings, like you can enable the Wi-Fi. Okay, so you can enable the Wi-Fi, or you can do much more. Okay, you can source an hotspot, or you can make your hardware connect on existing internet. You can do tremendous amount of things, so which makes it suitable for your IIoT ecosystem. right? So what's next? So once you have the hardware in place, your hardware should be capable of communicating to a centralized router. So when you talk about IIoT, you will not have one thing. Okay, sometimes you will have multiple things, and in order to facilitate communication, these multiple things will not be directly connected to the internet. Okay, rather it will be connected to a router, a centralized router. Okay, because we don't know in the factory how much device will be there, and it will not be very good idea to connect each and every individual element to a directly to internet, because if you connect it directly to internet, individual systems is going to have be assigned individual account, and individual number will be assigned. Okay, individual connection will be assigned. That's going to make it more costlier. Okay, if the requirement is like that, yes, you can go on. Okay, but most of the times you can have it connected to a common internet network, and from that common internet network you can communicate. So how to make this connection? So if you see there is a local network which needs to be implemented, okay, in this thing, you will get to make communication from your thing to a common router, and from the common router to your cloud. So basically connectivity. So this thing, okay, can have multiple options. So if you see, there are plenty of options available. Okay, apart from the things, okay, so if you see there's a gateway design which can be done. Okay, so you have like stacks of Bluetooth is possible for connectivity, Zigbee, Wi-Fi. Okay, there are plenty of other things that are possible. Okay, so if you see there are exhaustive list. Okay, out of which your Myrio already has Wi-Fi in it. Okay, meaning we don't have to deploy a separate hardware to do this. Okay, your Myrio itself has a Wi-Fi. That makes it much easier. And ultimately, security is a very important role. Okay, firewall and VPN can be implemented. So, like for security, if you see inside your NIMAX, there's something called security management. Okay, for which in order to make the communication, okay, you have to, you can, if required, you can make a certificate. Only if the certificate is matching, okay, will the connection will be established and will the data be communicating. Okay, if it is not matched, then there is a chance that this communication will not work at all. Okay, so that level of flexibility is available. Okay, you can have multiple nodes, and all of these nodes will be connected to the common gateway. And that could be a Wi-Fi, that could be wireless sensor network, okay, that could be LoRa. Okay, so plenty of technology, wireless stacks are available, wire and wireless communication protocols are available, okay, to implement this local network. Okay, from your thing to router. And from a router to internet or intranet, you can use some other stack to do it. That will become wide area network then. Right? So we need to consider many things. Okay, like what is the frequency, what is the data rate, maximum data rate possible. Okay, those things should be considered. Right? So yeah. If you see as frequency increases, you can see data bit decreases. I mean, as the frequency increases, data bit also increases. Okay, directly proportional. Okay, but distance ultimately it decreases as the frequency increases. Okay, here if you see this is the minimum frequency, and you can very clearly see that it's going to be from 100 to 300 meters, 10 to 300 meters. But Bluetooth is only 10 meters. Okay, but even though its frequency is high. Wi-Fi on the other hand, it's going to have multiple frequencies. Okay, it's going to have high data rates. Okay, but distance is going to be from 10 meter to 100 meter theoretically, but practically we haven't seen that much anywhere. Okay, so it will be within 100 only. And as the frequency data rate increases, okay, your power rate, okay, so if it's decreasing, it will also be less, directly proportional. Power consumption, okay, for a Bluetooth, for IEEE standards of this, okay, is very less. Okay, but for Bluetooth, if you see there's like low power consumption, not very low, okay, but low consumption, and Wi-Fi on the other hand is very high. So yeah, and as the more devices increased, okay, in order to address the devices separately, also we have a problem. Okay, so IPv6 is very important for IoT. Okay, so previously when 32-bit address was there, okay, 4.3 billion devices was possible. Okay, but nowadays IPv6 have come. Okay, and we have already gone above this 4.3 billion address combinations. Okay, we have 50 billion devices in the. So 50 billion, we cannot have only 4.3 billion positive connections. So that's why we have this IPv6 now, okay, which gives us plethora of options. So once the connectivity in local connectivity is done from your router to cloud, how do you make the connection? Okay, so there are plenty of ways, and also it depends upon the type of cloud you're going to use. Although it may sound good for us to make our own cloud, purchase the server and setting up, okay, the amount of expertise which is required is going to be very, very high. And most of us wouldn't recommend to go for it. Okay, it's always better to make use of something that is already available. So instead of buying expensive hardware, okay, it's better to go for an existing cloud, tool set. Okay, but if I'm using this, okay, you can see that the cost is also decreased. Okay, and whenever you need only, you have to pay and use. Okay, if you don't need it, you can stop payment and it's not going to be in use. Right, so when scalability is required, okay, today one requirement will be there, tomorrow some other requirement will be there. So depending on the requirement, okay, you can set up your devices. But disadvantage for this is data ownership. Okay, it's going to be less. Okay, so you're not going to be the owner of your data. Some third-party company is going to be, the owner. Okay, and if it crashes, okay, so you have to be at the mercy of the company who is hosting your drive to immediately fix it, or else the angry calls will be made not to your cloud provider but to you, and you have to you should be answering to each and every of your clients. Okay, an example for this is Google Drive. Okay, is able to hold massive amount of data. So Gmail, etc., etc. And protocols. Okay, that before one was connectivity, but now to transfer data, you need to transfer it in a form which is acceptable by the functions. Okay, if you see, these are the protocols that are supported for connectivity. Okay, like commonly used protocols HTTP, MQTT, APMP, AQMP, WebSocket, DDS. Okay, these are types of functions or toolkits which are used. Now, an important question to be answered. like everything is okay, but what do we make use of to program this thing? So I already told that LabVIEW is used, but now the important question still lingers. For I'm not sure how many people have not even heard of the LabVIEW hardware, LabVIEW software. Some people might be new. Some people might have already known. But anyway, to give a brief introduction about it, LabVIEW is uh, a graphical integrated programming environment, okay, where you don't really code anything, okay, but you make use of the bits and pieces of code together and combine it in a way that is going to be useful for you. Okay, so if you see LabVIEWs here, you can employ addition function to add two numbers. You can do something called as, you know, um, to avoid the inclusion of spaces. Okay, so you need to include some sort of algorithm to remove spaces. So that needs to be used. So not develop all these algorithms. You don't have to develop in other programming languages and call it in LabVIEW, because LabVIEW itself is a programming tool, okay, which will have a lot of inputs and outputs, which may have lots of input outputs to solve your problem. And most importantly, your LabVIEW hardware is very capable of computing with its hardware, so connecting with your hardware and communicating with it. So in this case, it was able to communicate with several hardwares, okay, and get the data from that hardware to your computer. Okay, and by using this hardware, what you can do, you can set the lifetime of, you can do the condition monitoring, you can evaluate the lifetime of the vehicle, and you can also simulate the hardware without having actual hardware. Let's say you want to test the battery. Normally, people will take the battery and they'll run the test sequences. Okay, but even before having the hardware test, you can actually run something called as, you know, speed. Okay, even before having the hardware, you can run something like HAL. Okay, where you can deploy the model of the hardware, say your hardware, and that will be acting like it is the product itself. So, what exactly is this LabVIEW? Okay, LabVIEW actually stands for Laboratory Virtual Instrumentation Engineering Workbench. Okay, it's basically a tool which is used to implement the stack, the programming stack for any part of application. Okay, since we need to observe the data in a remote world and control it. Okay, LabVIEW has all the essential tools to talk with the hardware. Okay. Okay, and more importantly, LabVIEW is not only software, okay, as more people think. Okay, it's both software and hardware. Okay, software is basically highly customizable. Hardware will be top-notch hardware. Okay, it will already have these specifications related to industry. Okay, and it can be extendable if required. Okay, so let's just get inside LabVIEW and see how exactly we can program it. So once you know open LabVIEW, okay, this is the first window you have to be seeing. So this is how LabVIEW is going to be looking like when you start it. But once if you finish it, okay, you can just go to file and something called new VI, through which we can initiate the programming. Okay. So how do you program it? How to write a very simple program? So LabVIEW programs are basically, flowchart based tools. Okay, meaning you'll drag and drop the flowchart based objects into your block diagram, and the front panel will bring it alive. Okay, so how do you do that? So first thing you do is, whenever we are working with IIoT, so first thing which is required is you need to have inputs and outputs. Okay, so if you see in LabVIEW, we can start programming right away. Okay, you don't need to remember any syntax and stuff because left click is going to be a helpful program. Okay, when you left click on your front panel, you get options like this. Okay, you can see that there's a input and output with respect to numeric. Okay, there's the input and output with respect to boolean, and there's the input and output with respect to string. Okay, so right now I'll just give numeric input. Numeric input means numeric control. I'll pick and place. Okay, so once you pick and place it, you can name them whatever you want. It's going to be input. You can place as much as inputs as you want. Okay, and to view the output, we'll be having something called indicator. You can name it as C. So once that is done, you can right click here, go to numeric, and click add or multiply. Right, so I just have to pick and place it in my front panel and block diagram. So this function comes up. Okay, so how do you make the connections now? So I made the connections by just clicking on the terminal where I need to make the connection to the place where I need to make the connection. So from here to here, see the answer. So from here to here also I make the answer. So then after this multiplication, you just click on this output, right? So this is how you process it. So instead of typing in scratch, okay, so most of the people will be not able to interlink between what is the flow and what is the programming, okay, because most of the people will plan in flowcharts and write the program, convert the flowchart into an actual programming language, okay, text-based programming language. Sometimes there will be a margin of error. Okay, and to provide that, if you see LabVIEW itself is a flowchart. Most of the engineers will spend a lot of time planning with respect to flowcharts. And here you have the flowchart itself. Okay, so like get inputs means first you can have A and B, and let's say you want to perform some multiplication. Okay, you have this numeric functions which you can make use of. Okay, then you can pick and place it here, and then connect it over here. Okay, so once this processing is done, you need to connect this output to an indicator. Okay, so basically what I mean by controls indicators is your LabVIEW programs will have inputs and outputs like any other programming language. But since LabVIEW is typically started off as using in instrumentation, which is widely still used in instrumentation, you'll find inputs and outputs as in instrumentation terminology called as controls indicators. Okay, control is something which can be controlled in instrumentation. So like you can control the value of output voltage for a power supply. Okay, you can control the frequency for a function generator. Okay, so these are called the controls. Okay, you'll typically use a knob control to control the voltage. Okay, an indicator typically is going to view the output, make us view the output, and that's going to be in the form of outputs. Okay, so outputs are also called as indicators, and you can see the output by clicking on the indicator. So you just need to make the connection. It's like electrical circuit which needs to be computed. So we just make the connections, and we can make it do it. Okay, and not to test it, you can just click give like 10 and 20. You can run this. It's going to become 10 into 20 is going to become 200. Okay, so now let's say you want to implement a condition checking. So for condition checking, we need to implement something like an expression in other programming language. But in LabVIEW, we have wide range of functions, like let's say a comparison function, which is going to help you, check conditions. So let's say you want to check whether the output of this multiplication is going to exceed values like 100. So what you'll do is you'll just make this a given function. Okay, you'll connect the first one here, and second one you just give the some threshold like 100. Okay, and you make the comparison of the output by using this function. Then output, if you want to view it, basically comparison is going to be true or false, and for it we have separate programming. Okay, like we have something called as LEDs. So true or false, instead of saying true or false boringly, okay, we have this LED available. So this is of course configurable within the data. So we can have like okay, so I'll set 1,000. So once if it goes above 1,000, okay, it's going to show 101 to 10 is going to be equal to 1,000. So it's going to be able to send us these values. So that's how we make use of the LabVIEW program. So LabVIEW is generic programming language, doesn't sound bad. Okay, but for IIoT architecture, if you see, we should be able to program the embedded system. We should be able to access the protocols, okay, local internet protocols, and we should also be able to communicate with the internet, okay, by using internet protocols. And by using this internet protocols, we should be able to communicate to cloud. So now our question is, does LabVIEW have these capabilities or not? Let's check that out. Okay, right now, if you see LabVIEW is able to run programs in my computer. Okay, apart from that, it is capable of doing a lot of other things as well, like accessing files, generating reports. Okay, out of which everything is very important in IoT application. Okay, apart from that, if you see, LabVIEW is also able to work with hardware. Okay, you can see that this Rio hardware which you are speaking about, we can program it by using your LabVIEW itself. So I can start programming my hardware by using my review. So it will take some time. And you can see that directly by using LabVIEW itself, instead of converting the LabVIEW program to, let's say, a C program or embedded C program, I can directly access my LabVIEW itself, because inside my Rio itself, you can install LabVIEW. LabVIEW will already installed. And you can organize your programs in such a way that it's going to be organized into a project. I can say something like IIoT. Okay, I'll set it in my desktop. Okay, and you can see my computer. Basically, if you see your embedded device will not have a display, meaning you cannot program anything. Okay, you need to use computer only for programming and deployment purpose. So your thing will be programmed. The thing will be connected to a lot of sensors, and that sensor will act like a thing. Okay, it's going to acquire data from the things, sensors, and it's going to be connected to your computer, no internet. So if you see, there are plenty of features available, like 12 analog inputs, which means 12 types of sensors will be connected. Okay, 8 analog outputs, which means you can generate some 8 different types of signals. 40 DIOs, meaning you can control like relay sets, 40 types of relay sets. Okay, out of this 40, 8 can be used as PWM, possibly to create an inverter. Okay, so like if you want to create a 3-phase inverter, you have 6 switches, let's say. Okay, for each and every MOSFET, you can send different types of signals. Okay, depending on your usage. Okay, so 8 different types of PWM is available. And other things that are highly crucial for IIoT. Like not all of the times we'll have sensors which will be giving voltage. Okay, sometimes your sensors will be protocol based. Okay, like SPI, I2C. That also needs to be done. So that will also be here. So if I give OK, for me, a wide range of functions will be available. And not to program this, I don't need to learn anything from scratch, because let's say I already know LabVIEW. Once I know LabVIEW itself can be used to program these things. Okay, it will form a model and will be created. Okay, you can see here that I have a computer, and here I have a MyRio also. Since 2 computers are there, both of them can be easily programmed. Okay, and if you see under my MyRio, I have separate VA. And they have given us a template, okay, which can be used as a starting point of your application. Okay, if you see, they have also given a template which you can have starting as a user starting point application. In this case, they have already made use of an example program. Okay, we're just going to just read the accelerometer value and just display it as an output in the form of some graph. The other reason why people go for LabVIEW is visualization is very, very easy. So apart from programming, okay, viewing the output also can be visualized. Okay, you have something like charts and graphs, which enables you to visualize the output in a way that people can understand easily. And program also, if you see, it's not really going to be very hard, to be honest. Okay, with minimal training, okay, you can start programming it right away. So the program is also very straightforward. So they just use a function which is going to fetch data from accelerometer. This is a block of code. Okay, and they combine this block of code to present it in a waveform chart. Okay, so when I run this program, you can see that it will start deploying. Okay, you can see that the program I have written in my computer. Okay, and that will be deployed inside my real-time hardware of Rio. This is IIoT hardware. So you can see that it's getting data. Now I can just make some display, the disturbance. Okay, on top of the Rio. Okay, and this is going to be plotted as a waveform. Okay, in my LabVIEW. And it's not simulation. Okay, I'm actually holding my Rio in my hand and I'm just making this perturbations, which is getting logged. Okay, so this is how we do it in LabVIEW. Okay, this is raw data. Okay, voltage data, or in this case it's accelerometer data. If you want to make some insights from this, okay, basically you can see that there's a in the inside LabVIEW we have several types of uh, several types of libraries are available. Okay, maybe inside LabVIEW we'll have it, or sometimes we need to install from NI website, or some third-party instruments are available, third-party drivers are available, third-party libraries are available. Okay, so here you can see, like, if you want to process images, okay, you have separate image stuff. Okay, if you want to process waveforms, okay, you have signal processing available. And if you want to implement a control system, okay, you have a control and simulation toolkit available. Okay, if you want to combine all these toolkits to create an application, yes, of course, you can combine them. Okay, you have robotics, you have, of course, in order to access the hardware-based information, you also have this MyRio toolkit available, this library available, which with minimum programming language, okay, you can access the hardware. Okay, let's say you want to access the hardware. Okay, you'll place this inside a loop. Okay, there's a loop concept inside LabVIEW as well. And let's say this data is not a generic input and output. Let's say this is for biomedical. You have biomedical signals also available. Okay, and depending on the requirements, you will have like different toolkits for different purposes. So that's what we see here. Okay. So your LabVIEW program is going to have front panel. Okay, it's the place where you introduce inputs and outputs into a program. That is also called as controls indicators, basically user interface. Okay, typically in IoT applications, this can be used to create a dashboard where you can remotely monitor your status of your application. And block diagram is a place where you write the logic behind your application. Okay. So, and the coding style is basically the block of pictures you're putting together, and it makes it, appear to you. And IOs also, if you see, they can be rearranged. You can create a GUI as soon as you can creating a program. Okay, it is happening concurrently. When you're creating logic itself, you are able to create your GUI as well. And apart from that, as I was saying, LabVIEW has several toolkits and drivers available. Okay, and apart from NI hardware, because most of people think, okay, LabVIEW is a NI hardware, NI software, meaning it can only interact with NI hardware. Not necessarily. If you want to implement some applications using third-party applications hardware as well, okay, if you see there are stuff which is available to interact with non-NI hardware as well. So drivers are available basically. So if you see there's something called Agilent, Agilent is not NI, okay, it's a third party. If you want to acquire data from an Agilent hardware, okay, you can install their drivers, okay, so that it will be available in LabVIEW. Okay, if you type Agilent, whatever product you have to Agilent you're going to use, space LabVIEW driver, there is a chance that they are going to be providing it to you. You can download it and you can install it. Okay. So where exactly do you use this? Okay, so where LabVIEW is going to be used for the edge device for things. So if you see, we have the hardware with us, okay, which is capable of acquiring the signals. Okay, these signals in turn, okay, could be used for, in this signal acquisition hardware could be used for acquiring signals like from bearings. Okay, if you're trying to monitor a machine, electrical machines, okay, like gears, status, or speed of the motor, or pressure in a valve, okay, displacement, or electrical power, okay, you can acquire voltage waveforms, current waveforms, like that. If you want to acquire, you have a separate sensors with us, okay, it's going to give you output in terms of voltage. That voltage can be read by several type of hardware cards available. It could be temperature. Okay, but once you bring it inside your hardware, this data inside hardware, you should be able to convert it into a format which is understood by human beings. Okay, then communicate this data to some external world. Okay, so which means that hardware should be able to think. Okay, it should be able to sense, and it should be able to alert. Okay, think in the acquire in the sense is going to acquire the data, and based on the data acquired, you should be able to think. Okay, what should I do with this data? What do I understand by this data? Okay, so I should have an analytics program inside. Okay, which is going to continuously monitor the status and the status of the hardware. Okay, let's say if you want to see whether this hardware is going to fail within this specific period of time, you need to have a hardware in place. So it should be able to think on its own. And if some anomaly is detected, okay, it should be able to alert. So due to that, for embedded controller, okay, you can have possibly this Rio controller. Okay, it could be a Rio, compact Rio, or it could be the My Rio, which I have it in my hand. And these things could be programmed by using LabVIEW. Okay, then after we program it, after we get the data, we have the ability to think right now. Okay, next is communicating this data to some other location. Okay, so I'm sorry about that. Okay, so communicate this data to a cloud location. Okay, so to communicate to the cloud location, we need to have a appropriate protocol. Okay, we cannot directly connect to cloud. Okay, possibly to a centralized location. From there we can connect it. So in order for thing to communicate from your location, from your thing to your router, there are several protocols available. Okay, so like OPC is available, DDS is available, MQTT is available. Okay, so these are commonly used IoT protocols. Okay, so which will help communicate data from your edge devices to your router. Okay, and from router, basically you can make use of internet protocol, okay, to connect to your cloud. Okay, but since your thing, okay, will possibly have a very small form factor, it may not have huge processing capability. Okay, for high level processing, people will bring their data to cloud. Once the decision has been made, the decision will be given to your thing, and that will be processing it. Right. So in order to make the data transfer as low weight as possible. Okay, you should not have it heavy weight, because most of the time things will require low power requirements. Okay, it will not be always switched on, and it will not be always connected to internet. So it needs to conserve battery, right? So in that case, it needs to have protocols which are not very power hungry. So these protocols are less power hungry. Okay, and depending on usage, different types of protocols will be used. Okay, sometimes server to server communications will be used. Okay, sometimes device to server, and sometimes device to device communication. Okay, server to server communication means if you have two applications to communicate, that is going to be server to server. Okay, so but most of the time device to server is what we need. Okay, so which means from your hardware you need to communicate to server. Okay, so that is going to be you might use HTTP protocol, XMPP protocol, or MQTT protocol. It's going to transfer data. Sometimes you need to have device to device protocol. Okay, so in autonomous vehicle, if you want to check whether any device is coming in front. Okay, in that case, whatever is in front of you, you need to communicate with it. Okay, and it needs to be as fast as possible, and it needs to be behind in front of device to device. Okay, your one autonomous vehicle is device, the other autonomous vehicle is also device. So to facilitate communication between this, you'll have some protocols. And this data will be brought to some popular IIoT platforms, okay, for heavy power processing or to derive insights. Okay, so basically we have several types of platforms available. Tomorrow we'll be seeing about them. Okay, when we deploy an application, we'll see how we use all these things for our requirement. So plenty of IoT platforms are used, like Amazon is used, PTC ThingWorks, IBM Bluemix. Okay, Google Cloud will be used. Okay, so this will be used for monitoring the data from anywhere over the world. Right? So in LabVIEW, if you see this protocol, common IIoT protocols. Okay, so if you see, we'll be having it all available. So in data communication, we have OPP UA available. Okay, we have RTA DDS available. Okay, and protocol, we have this HTTP also available, which we can make use of. Okay, apart from that, we also have TCP AP available. Okay, communication based, low level protocols like TCP IP, serial communication. Yes, so those are also available. And also for, let's say, if you're going to go for automotive, CAN protocols are also going to be available here. Okay, so depending on your requirements, you can use whatever is most apt for your application. Okay. So yeah. So let me know if you have any questions as of now. I will address them. Okay, you can chat in the chat box if you have any questions, or you can unmute and ask a question.
So I'm requesting the participants, please put your questions on the chat box so that it should be an proper interactive section. So participants, please put your questions on the chat box. Make the session completely interactive.
Oh, okay. You need my contact number? Yeah, sure. I'll just share my contact number. Anyway, I'll share it at the last.
Okay.
So tomorrow we have one more session where we'll do the implementation part of this. Okay, so which will give us a clear idea on how it's actually used. Right, but if you want my contact number, yes, you can take use of it.
Thank you, sir. It will be a great session so that we can just know the practical implementation. I think today there is no questions from any participants. Participants, please just note it down, take a snapshot or search name, email ID and contact number. Okay, sir. Thank you so much. It's a great session. It's great learning. Tomorrow again we'll meet at the same time for your lab session. In the
Yes.
second or tomorrow.
Yes.
So here I'm just concluding this session, and thank you so much. You may just proceed for your lunch, and after lunch we'll meet at the session we'll start the session at 2:30. So 2:15 or 2:20 onwards you may please join. So thank you so much. See you tomorrow again, sir, Mr. Rajkumar.
Yes, ma'am. Thank you very much for having me here.
Thank you.